understanding the bean life cycle, what happens behind the scene. Okay. Okay. So any Java application, if you take, okay, there are three phases. One is initialization phase, where you can do preparing the use of the space and create an object which need to be initialized, and certain things where you wanted to create a configuration and allocate the system resources, you will be doing that. Okay, like initialization method, caching it, allocating the system resources, like creating a connection pools, things like that. So all comes in the part of phase called, it is an initialization phase. Once the initialization phase is completed, you will move on to the next phase, which is an use phase. So use phase is where like the request will be coming from your client, and you process those requests and process it, and come out with a response what you wanted to send it to client and complete that. Okay, most of the object which is created, or most of the resources what is created in the initialization phase, will be used in the use phase. Okay, and finally, once you're done with your application usage, when you close it, okay, so it will go to the destruction phase where you will shut down, and all the system resources what you allocated in the initialization block which will be get released and made eligible to garbage collection. Okay, so these are the three different phases of any Java application. If you look at whether it is a test case, or whether it is a standalone, or whether it is a web application, it really doesn't matter. The same life cycle applies for the all class of applications. Okay, and in a specific phases, Spring roles some important role in all the phases. Like it does something in the initialization phase, in the use phase it will do something else. Okay, and in the destruction phase it does like cleaning up all those things. Okay, and the life cycle is the same for all three dependency injection styles what we have discussed so far, like Java configuration, annotation, and XML. It is the same. Okay, only the path will be taking different, but the overall cycle will be the same cycle, and we will look into that. What are those? So let's go one by one with the different phases, what it does behind the scene. We'll try to understand. Okay, so when you create an application context using this annotation config application context, given this Java configuration, what happens behind the scene? What did we understand so far? Can you tell me what happens behind the scene? When
The application context, that is the container, gets created, all the beans in the given configuration are created, and of course the resolution in terms of the dependency happens later on based on what type of the scope. Resolution can be based on the dependency, resolution can be based on the scope of the bean. Yep.
right,
And then the post process, I mean, the post construct method gets called.
right, right. So so far we have discussed like when the application context loaded, so it loads this bean definitions and does the constructor dependency injection, setter dependency injection, and then post construct will be called. So those things we have already discussed. So we'll take a little more high level look at what happens behind the scene. When you start creating it at the high level, it loads the bean definitions and it does the post processing the bean definitions. And once it is done, this is at the XML or at the Java configuration level. Inside that, for each and every bean, okay, it goes and creates a constructor dependency injection, instantiate the beans, and if there is a constructor dependency injection, it does it, and then set a dependency injection, and then it goes through a process which is like bean post processors. Okay, inside that you have bean post processor before initialization, and initialization then after initialization. So once it goes through that created bean through this bean post processor, and then the bean will be ready to use. Okay, this is what happens at the high level. Okay, what we are exposed or what we have seen so far is Bean definition loaded we have seen, and instantiating the beans using a constructor dependency injection and setter dependency injection. And also we have just discussed small portion of this initialization. So this is what we have seen so far. Okay, we'll talk about all the other components a little more detail. Okay, what happens in each blocks. If you look at this loading bean definitions, okay, bean definitions are get loaded and does the bean post processing the bean definitions. Okay, what does it mean? So loading a bean definition, that means definition can be loaded in different ways. So one is, if in case of Java configuration, it looks at this at configuration annotation, and it loads all the methods which is having a bean annotation, and start creating a definition for each and every at bean annotation methods which is there in the configuration class. So first it loads all the definition, and it also puts the default things if it is you are not specified, and it also does all the default initialization everything. That is in case of Java configuration. In case of XML, it loads an XML file and parses against with an XST what you have added part of your configuration. And it loads all the XML files, XML definition into a memory, and a kind of it creates a DOM motion of the XML. Okay, so now all the definitions are there loaded in the uh, memory. In case of uh, annotations, at components are get scanned through component scan, and all the definition again gets loaded into memory. So in this part, bean definition, whether it is a Java configuration or whether it is a annotation or whether it's an XML, all the definitions will get loaded into a memory. Okay, with the different approaches. So once the definition is available, this definition will be given to the post process bean, okay, to modify something on it. Okay, this is a special extension point. Okay, it can have an ability to modify the definition. So what we are talking about in this phase is, in this block is only at the definition level, not by individual bean definition. It is at the system, like all the configuration definition level. So inside this you have all beans definitions, the complete XML file or complete Java configuration file, like that. Okay, so now when you actually load the bean definition, let's say you have this in a Java configuration class, it loads all these bean into an application context as a definition. Still the object is not get created. So there's a component called like bean factory. So this Java configuration bean definition will take this all the metadata what you have given to create this bean. It'll take it and create a kind of bean definition entries. This is not the object yet. Okay, so take this transfer service as a bean ID and put all the information what it is there along with this method has been given, it will add it. It is the same thing as in case of XML. XML file like bean ID, class, and constructor dependency injection, setter dependency injection, all other parameters which you have specified in the XML definition gets loaded into a bean factory as a DOM version of it. Okay, and if you have other files, like you have given application config and there is an infrastructure configuration, then it takes the definition from the infrastructure config.java configuration file and gets added to the bean factory. Now this bean factory contains the complete definition. Again, I'm re-emphasizing here is it is a bean definitions. The objects are still not created yet. Okay, so now this definition is given to there is a special extension point which is called like bean factory post processor. Okay, it does some post processing on the definition which is just loaded by XML file or Java configuration or through a component annotation scan, and it is given to this bean factory post processor, and this bean factory post processor has an ability to modify the definition. Okay, it can go and modify the definition of any bean in the factory before an object gets created. Bean factory has a Bean factory post processor is an extension point. Okay, and actually, like when I say Bean definition modification, that means like if you are given some definition where with an dollar sign with a key which need to be loaded or which need to be modified before even creating an object. Okay, so those kind of things actually does the transformation of the Bean definition. It actually takes the key and look at from the property file, get the actual value and put the actual value before even object gets created. So some sort of things like in this Bean factory post processor does. Okay, so it's all like you don't need to go and write anything Bean factory post processor, even though it is an extension point, and there are several Bean factory post processor already available in the Spring. You just need to go and configure them. That's all. You don't need to worry about writing anything unless you wanted to go and write something for your own special needs. You can go and implement your own Bean factory post processor by implementing this interface, which is like Bean factory post processor interface. It has a method. You go and take this method, and this is what it contains, the complete definition. Okay, inside this you can put the method and go and register this as a Bean. So let's take one of the existing Bean factory post processor and implementation to see how it works. Okay, so let's say,
Hello,
uh,
Manju.
yep.
Yeah, I have one doubt. Akhil here. Yeah, can you go back to the previous slide once, please? Yeah, here you said that applies transformation to the bean definitions. Is it at this point that it actually adds the aspect-oriented point cuts? I know I'm skipping a bit ahead, but just out of curiosity, I'm asking that.
Can we take this question later?
Yeah, sure, no problem. Okay,
Okay. Yeah,
fine.
sure.
Yeah, sure. Okay.
Thank you. I'll address that anyways. Okay, so now um, we have seen this one of the configuration where a property file gets loaded by this property placeholder. Okay, let's say I have a bean, like I have created an XML bean definition saying that like this is my data source and I have created a URL and the user and password, let's say. So all these keys I have given with a dollar sign with the flower braces. Okay, and I have put all this key and value into a property file. So this is my property file. Okay, and this property file gets loaded through a property placeholder which is coming from the namespace called context. Remember we discussed about this. Okay, so this behind the scene, this tag has an implementation to a specific class. Okay, that class is an implementation of Bean factory post processor. Okay, the Bean factory post processor interface has been implemented behind the scene. One of the implementation which is tagged behind the scene is property placeholder. So when you set this property placeholder behind the scene, it is going to use the Spring Bean implementation, and that takes up setter method as a location to inject this property file. So this guy will load this property file, and it applies this transformation to the Bean definition. Okay, it search this DB URL. If it is there, it will go and replace this value here. Okay, so this transformation will happen before even object gets created. So it goes and updates the definition. So modified Bean definition in the memory looks like this after going through Bean factory post processor. It will not be an XML, but modified definition, it will go and replace this with an actual value, and with this you can go and create an object. Okay, so this has been done by using one of the Bean factory post processor implementation. So I'm just setting up here. So this will load and does this changes during the Bean factory post processor. Okay, so that's about how the Bean post processor Bean definition works. Okay, now once this all the Bean definitions are modified and updated in the Bean factory, okay, then the modified complete definition is given to the next phase where you can go and create bean by bean. It will take the complete bean factory object where it has a definition for each and every bean, take one by one bean in an order in which it has to create. So already this, while loading the bean definition, it is already created the indexed based on dependencies. Okay, so least dependent bean definition will be picked up to create an object first. So it will go through the creation process. First, it will take the bean which has the least dependency one and create instantiate the bean object and does the setter constructor dependency injection and setter dependency injection and come to the bean post processor and then ready to use in your application. Okay, so in the initializing bean instance, all the beans get instantiated by upfront by default when the context is getting created. Like each and every bean eagerly instantiated by default. That's the default behavior. Unless you specified the any bean definition you wanted to or as a lazy init. Okay. Otherwise, by default, all the beans gets created upfront, and it's created in the right order in which it has to be get injected. So all those things will be taken care by behind the scene. After dependency injection, for each and every bean go through post processing phase. Okay, it's like further configuration and initialization can be done on top of the created bean. Okay, once that post processed object goes through like post processing phase, okay, those beans are fully initialized and ready to use in your application. Okay, and the reference of all the beans which is created by the container which is there in the right scope other than prototype. Okay, so those things will be tracked in the context till the life cycle of the context is destroyed. Okay, that is what happens in the initialization phase. So let's take a look at what is this bean post processing does. So if you look at this bean post processing, we have two things. One is like initializer, and there is another one is before initializing bean factory post processor, and after initializing there is a bean post processor. Okay, remember we discussed about the post construct. Okay, the post construct, when you do a registration with the Spring framework with this annotation, call me back this method when all the dependency injections are completely done. So this is a bean post processor which actually goes and invokes that method after the dependency injection is done. The part of bean post processor, it takes care of it. Okay, the other two will allow you to do some additional configuration, and this has an ability to modify the object itself. Okay, there are two bean post processor here. One is this, and another one is bean post processor before and after. Okay, so now if you look at the initializer which we saw, that post construct annotation which I've added this, and this method will be invoked by this bean post processor. Okay, in order to make this activate in the XML configuration, you need to go and add this context annotation config. Okay, in case of XML. In case of Java configuration, you just need to do a component scan. Component scan annotation you need to do. So behind the scene, when you configure this like component scan or annotation config tag, if you add behind the scene, it will go and declare several bean post processor. Okay, one of the bean post processor which is already included is like part of this is common annotation bean post processor, which will go and scan this post processor behind the scene. So this is the implementation which will go and scan. So this there are several bean post processor will get set up when you do this annotation config. Okay, this is the guy which will go and do it. Same case when you do the Java configuration, when you call this annotation which is a component scan. So behind the scene, it will set the several bean post processor for you. Okay, this is in case of Java annotation, and this is in case of an XML configuration. Init method equal to a method name. Okay, so this is about bean post processor initialization. and there is a Bean post processor for the before initialization and after initialization. And this is one of the special extension point in the Spring. Okay, this Bean post processor before initialization can modify the Bean instance itself. Can you imagine modifying the object itself? When I modify, like it is like it can go and take the existing object and create a brand new object and return the brand new object, or take the object, originally created object, modify something, add or remove something, and return that object, or create a new object and keep the original object inside the new object and return the new object. Okay? This is really a powerful extension point, and it enables a lot of features in the Spring framework. Okay, and again, Bean post processor is an interface. Okay, there are already Spring provides a several implementation of this Bean post processor. So you don't have to go and implement for anything for new thing, unless you wanted to do some special things for you to take care of it. If you need, you can go and write your own Bean post processor and register it in the or create it as a Bean and plug it in. Okay. Most likely you don't have to go ahead and write your own thing. It is not really common. Maybe you will be using it, already existing one. If you want to implement, you must go and implement using this Bean post processor and interface. Okay, this is one thing, and this is an interface. The Bean post processor has two methods, and post process after initialization and before initialization. Okay, and if you look at the method signature, it takes an object and a Bean name and return the object. So in these methods, you can go and take this object, extract some information, create a new object and return this object. The object which is written from this Bean post processor will be updated into a context. Okay, either you can go and modify the object, return the modified object, or take this object, throw away this object and create a brand new object with this and return the new object, or create a new object, keep the reference of the original object and return it. It has an ability to do that completely. So from now onward, we'll use this Bean post processor. There are several Bean processors. We'll be using it, and this will be created. This Bean post processing will happen after completely, object creation is done in the phase of initialization. Okay, and if you look at the configuration life cycle for different approaches. Okay, XML files will get loaded from the XML file. I request everybody to be on the mute. There's some noise behind participants.
Hey Manju.
Yep.
Hey, I have one question.
Sure.
Can you go to that previous slide, please?
Yeah.
I got that point that Spring provides an extension point where we can actually modify the Bean instances. Do you know any practical or use case where this can be used or applied? Or either way, is the question can be something like where folks are using this in actual Spring implementation?
In the Spring itself or outside the Spring?
Yeah, outside of Spring. I mean, just means context was where this can be used or where we are using this.
Okay, where we are going to use, we'll discuss in next upcoming session, because the next several courses, topics which I'm going to talk, which will be used behind the scene, all this Bean post processor, which is already implemented by Spring.
Okay.
Okay.
Thanks.
And most likely you don't have to create your own. Okay, unless there is a need to do something which you wanted to write another framework on top of it.
Sure. Okay.
Okay, but let's understand. See, all these things what we are discussing in this session, we will not be using it or going to implement it, or new implementation will be doing out of this. It is very important to understand what happens behind the scene, how it is being structured. That's
True,
critical here.
yes. Got it.
Hmm?
Okay, thanks.
Okay. And so we have seen the use case for initializer, because this is where I wanted that my method to be called. Okay, that initialization method. So the use case for this, okay, being post processor, I'll just give one use case where we needed this use case. So before initialization, okay, let's say I have done the constructor dependency injection and setter dependency injection. Okay, in case of setter dependency injection, okay, let's take an example of XML. Okay, in XML configuration, constructor, the object gets created through constructor, but even if you define the setter dependency injection, okay, a setter dependency injection is always an option. If you give the configuration instruction, it will do it. If you not, it doesn't do it. But object gets created anyways. It doesn't stop you to create an object. Let's say I have some three setter dependency injection, and these are an optional dependency injection. But later point of that point, I found that one of the setter dependency injection, I want to make it as a mandatory. Okay, here is an option is I can go and change the constructor and pass the constructor dependency injection. That is one option. Otherwise, I can actually go and use one of the annotation, which is called as a required annotation on the setter. Okay, when you use the required annotation on the setter, that you are marking it as a mandatory dependency injection for setter. Then in the XML file, if you are not given the configuration instruction, then this bean post processor will go and validate that object. Has been all the mandatory setter dependency injection has been done. If not, what it does is it will throw an exception. You have put this, there is a required annotation for the setter, but you are not given a configuration instruction in the XML file. And it will throw an exception and it will stop creating a context. Okay, that's one use case. Okay. So we'll talk about this later, bean post processor, after initialization. Okay. Now, if you look at this configuration lifecycle, whether it is for XML, annotation, or Java, okay, the bean definition for XML will be loaded from the XML file. Okay, for annotation, it will be loaded from the component scan, and for a Java, it is loaded from the bean method part of configuration annotation. Okay, then all this definition will go through bean post processing phase. Okay, if there is any dollar sign or anything which is been marked in several configuration, it will go and change that transformation has been done on the definition, and modified definition is going to give it to the next phase where it will go and create a bean instantiation and constructor dependency injection, and does the property dependency injection and goes through bean post processing. Okay, and in case of annotation, using AutoWare, both this constructor dependency injection, setter dependency injection, field dependency injection will be done here. Okay, so both the things will be taken care. And in the Java, in the method itself, has this implementation to do a constructor and setter dependency injection. So whole thing will be taken care. So created objects for all the different approach will go through this bean post processing. It's a common for all of them. Okay, so that's one thing. And if you look at the whole life cycle of the initialization phase, so we discussed about the bean definition loading. It does this loading a definition, creates an order in which it has to create, and modifies the definition using a post process bean definition, using a bean factory post processor. And modified definition is given to create an object one by one. So this whole cycle will repeat for each and every object. Okay, instantiate the bean, constructor dependency injection, setter dependency injection, and then it validates if the bean is created fully or not with some bean post processor, and then invoke the callback method where you have put the post construct, and then it goes through bean post processing, and then it validates if the bean is created fully or not with some bean post processor, and then invoke the callback method where you have put the post construct, and then it goes through bean callback method, and then it validates if the bean is created fully or not with some bean post construct, and then invoke the callback method where you have put the post construct, and then it goes through bean post processing, and then it will put into container and ready to use in the application. Okay. Any questions so far? So the difference between this bean post processor and bean factory post processor, bean factory post processor at the definition level, bean post processor is at the object level. Any other question?
One question, Manjunath.
Sure.
This setter injection is mandatory by default, or
Can you speak a little louder to the mic, please?
this setter injection is required by default?
No, it is part of the process. If you provide it, it will does this setter dependency injection. If it is not there, it will not do it.
If there is no matching for the setter injection, so it will throw exception. I know that. But if there is a required required annotation I can use. By default, it is @required, or
no, by default it is not there. If you wanted to make the setter dependency injection for one of the setter method as a mandatory, then use that annotation at required, and that is being validated by one of this bean post processor. Before even initialization, I need to do it. Is it clear?
I think.
Any other question? Is it your question is being addressed or not? Hello? Did I address your, did I answer
Hello?
your question?
So my question is, if I don't use annotation, so if there is no bean which match this certain injection, so then it is a exception.
No, by default, setter dependency injection is an optional, right? Only if you have given that instruction, then the setter dependency injection will happen. Otherwise, it will not happen. Consider you are not given a required annotation for those methods.
My question is, if I don't have a bean mention which satisfies the certain injection, so the application on the startup will throw exception, or it will go through?
It will go through. See, as I said that setter dependency injection is optional, and it will go and create an object and it will proceed further. Okay, let's say that setter dependency injection, if you are using elsewhere, like in a part of the initializer, okay, and if it found to be null, it will throw null pointer exception. But context creation point of view, it doesn't stop. Okay, because setter is an optional, unless you go and make the setter as a mandatory by having the required annotation. Then you are forced to go and give that configuration instruction in the XML.
Okay.
Is it clear?
Yeah, I'll test this, because I was assuming that if I don't provide a bean
Right.
which is matching.
By default, if you don't provide, the context creation still goes through fine.
But I think I see exception sometime. There is no bean defined by this name which match this this setter method. I have seen this.
But so you have given a setter dependency injection, but if it doesn't match the right name, then those kind of exception will come.
That's why I asked if this is mandatory or
no, this is an optional. And if you have given a configuration instruction, you have to give it the right parameters, right things. If you don't give a right information, since you have given a setter dependency injection, if it doesn't find the details, it will throw an exception that time. You got what I'm saying, right?
Okay. Yep.
Is it clear? Maybe we can see that later.
Yeah. Okay. Yeah.
All right. Any other questions? Okay. Now we'll move on to the use phase. So now object creation, all the container has is all the Spring Beans created. It's available. So now in the use phase, so I'll go and do a lookup by context.getBean. With a bean ID, I go and look up and I'll get the object. And with this object, I'll go and invoke the method to do a transfer money from one account to another account. Okay. So we know that a Spring involved in this while creating a context, application context. So after doing a lookup, okay, when I'm calling this service.transfer or anything, is there any Spring involvement behind the scene or not? Do I need a Spring support anymore? Because I have already got the lookup and I have the object reference.
Hello?
No, Manju.
Yeah. So ideally,
Hello,
no.
Manju?
Yeah.
Yeah, I think it will be required. Maybe I'm wrong, but I think it will be required. Because if the bean which I have initialized is a singleton kind of bean, then the context reference, if we delete or remove the context reference or shut down it, the bean will also get destroyed.
Correct. But I'm in the use phase now. When I do a get object, okay, I'm talking about this specific line, let's say. When I'm using this object, do I need any Spring support behind the scene or not?
No, for this particular line, no, we don't require, because we are dealing with objects and their use case or methods. Right?
Okay.
That's why we don't require Spring in between.
Right. Ideally, it's not required because we already created an object and got the reference here. I'm just using it because I don't need any Spring involvement behind the scene. Right. Yes. So ideally, if you look at like this transfer service implementation has already created the bean in the container. I just do a lookup and I get the object. I invoke it. Okay. Simple invoke directly. There's nothing special about it. Okay. Let's say the transfer method. If I want to make it as a transactional behavior, okay, and I go and add this transactional behavior. I want to do something special around that object, that method, this transfer method. If I go and instruct saying that open the transaction before invoking the method and do everything and commit at that towards the end of the method or after completing the method. If I have asked a special instruction to do it, okay, then what Spring does is Spring will actually goes and wraps up with this proxy object. When I have given something a special instruction at the method level or something. Okay, so Spring will go and create this proxy object, which is called as a Spring proxy object. And within this Spring proxy object, it has a reference to an original object, which is like transfer service implementation. Okay, Spring wraps this proxy, and whenever you ask for a lookup of the bean, you don't get a reference to this transfer service implementation object. Rather, you get a reference to a Spring proxy object. Okay, and whenever you invoke this method, transfer method, first the request will be get intercepted by this Spring proxy object, and it kinds of like opens the transaction and invokes this method, and once it is done, comes back, commits or closes it. Okay, and this makes the Spring proxy makes things a little more interesting. And this happens only when you have given some special instructions or special configuration on the method or bean. Okay. This is something which is interesting. We'll discuss that a little more. Okay. So this proxy object, Spring proxy object, actually gets created part of the bean post processor after an initialization has been done. Okay. This proxy object gets created after initialization done, and if there is a special instruction, there is a specific bean post processor will go and scan. Based on that scanning, if it finds a special instruction is given, it will go and create a proxy object and wraps that additional behavior to it. If I am not given a special instruction, it will go with a normal way of handling the raw object. So this special handling will be done by bean post processor after initialization phase. After initialization, the block which is part of the bean post processor. Okay, this is the power of the proxy. The way it works is the Spring proxy object gets created by an interface what is being implemented by this target object, which is the original object. Transfer service implementation is implementation of transfer service implementation interface. So Spring proxy object will actually takes this interface and implements it. All the methods with our interface methods, what it is defined in this transfer service, gets re-implemented, and the request will come to those implementation first. Okay, and whenever you configure like special instruction, I wanted to have a transactional behavior to that method for the transfer service method, transfer method. Then I'll go and set up the Spring transaction manager. It will intercept. So that method will go and check. Okay, first it will go and create a transaction by using a transaction manager. So it will begin the transaction. Okay, then go to the actual method invocation on the original object, which is called as the target object, and process everything, comes back, and then commits it. Okay, this additional code has additional code or adding this behavior will be done automatically for you by the Spring proxy when there is an instruction provided. Okay, so this whole proxy concept has been taken from the dynamic proxy, which is a feature of JDK. In the JDK itself has a dynamic proxy behavior. Okay, using that dynamic proxy, you'll go and create this Spring proxy to add this additional behavior to make it work. Is this clear?
Question. So, if the Spring transactional interceptor is going to implement transfer service, so there might be the implementation class is where we are going to do the annotation at the rate transactional or whatever, right? Mm-hmm. So there might be other methods which are not transactional, right?
Correct. So those will be bypasses.
So it will still go through the transactional interceptor.
Right. So because you have already implemented this, and it will go and check an additional logic. If it is there, it will do it. Otherwise, it will not invoke.
Okay. Yeah. Good. Thank you.
Okay. So if you look at the whole concept here, right, which is actually like your decorative pattern. So on instead of going and writing another decorative pattern class on top of it, the Spring proxy will play that role. It's like you are decorating what you wanted before and after. If you look at the decorative pattern, so similar to that. Okay, so this proxy is based on an interface. Okay, Spring proxy object will get created based on the interface which is provided, is implemented here. Okay, there are two kinds of proxies. So far, we have seen this CGlib proxy yesterday about how the Java configuration gets extended by the Java configuration class and added the singleton behavior. So which we saw this. Okay, and today what we saw is the JDK proxy. JDK itself provides a dynamic proxy way of creation using this JDK feature. Okay, and there is already built in the JDK, and you just need a Java interface to do it. Okay, here it is just you don't need an interface. You can just apply on the actual class, and provided that the class should not have a final attribute. Either class or method should not have a final method, final keyword. Only in those cases you can go and create a proxy objects. Okay. So recommendation is code to interface, do the coding using an interface. So that uses a JDK proxy by default. Okay, that's the one. The way it looks is like JDK proxy which is interface based. You have an interface, the proxy gets implemented using this interface, and this additional extra logic will be added by the Spring itself, and it keeps the proxy object keeps the original reference to a target object. Okay, so here I don't have a interface, I have a class, and the proxy object is going to extend this class and keep the reference, and put an additional logic on and to apply on the target. So this is the way the CGlib proxy works, and this is the JDK proxies. Okay. So that's about.
Okay, Manju.
Yes.
Then whether Spring checks for every class that whether that class has been extended from an interface, and then it uses JDK proxy. Is that the way?
Yes, when it gets all the definition and creation, right, it knows. It is always internally it uses a reflection to get that information.
Oh, okay. So, I mean, if I put it in very broad term, then every time Spring uses JDK and CGlib proxy together, and it just determines which classes have been implemented. They are extending interfaces. If they are extending, then they use JDK proxy. Otherwise, those are final classes. Then it will use CGlib proxy. Is that correct?
Interface, it will use the JDK proxy, and the classes it uses a CGlib library. And if the classes which are final, it will not be applied at all.
Okay.
Final cannot be extended, right?
True.
Yeah.
Okay.
Okay, and since it is objects creation happens in the during the context creation time, so everything will happen before you start up using lookup. The proxy object gets created at the context creation time itself.
Okay.
The context creation happens here. Here, this Spring proxy object gets created here after initialization.
Oh, okay.
Okay.
Okay. Yes.
Okay. Okay. So now we'll move on to the destruction phase. In the destruction phase, when you like call this context.close, okay, then what happens behind the scenes, like any bean which you added this destroy method as a method to be invoked to clean up. Okay, so those method will be invoked before even releasing the reference from the container. Okay, especially for singleton, it has been taken care of all the prototype, since a container doesn't hold the reference. So prototype beans you will have to take care of your own. Okay, so these are the one thing. And in case of XML, you use the destroy method to configure this method to be called. In case of annotation, you use the pre-destroy method to get invoked by the Spring. And in both the case, either you need to have annotation driven or a component scan to scan this annotation. Okay, so all the beans get the one which is registered with this destroy method or pre-destroy method will get invoked by the Spring itself automatically to clean up this. Okay, so that's one thing. And usually it's sometimes it's not possible to call this all context.close every time. So you can go and register context with a shutdown hook, which is provided by JDK, which is already implemented by context. So when you say like context register shutdown hook, so inside this register hook, it like context.close will be called automatically, so that graceful application context will close even on the JVM exit. Okay, so that is possible. So what we have covered is initialization phase we looked at, loading bean definition, bean factory post processor, constructor dependency injection, setter, and bean post processor before initialization, and bean post processor after initialization. So we discussed about that. Complete the proxy object gets created in the initialization phase. Okay, and then when you use it, based on the proxy or whether the object is created with the original target object or a proxy, when you do a lookup, you get this. So that is why always you need to cast it to an interface, not to an implementation. So whenever you cast it to an implementation, and if the proxy object gets created, it will throw an exception. At that time, you'll come to know something has happened behind the scene as something magic. Okay, so either when you are doing a debugging or when you're casting to the implementation, and behind the scene if it creates a proxy object, then only you'll come to know something different things are happening behind the scene. So that's the magic. You can go and add it in the proxy object, add an additional code and things like that. Okay. And destruction phase, you can go and delete the and clean up the system resources what you have allocated.